So this is lesson 5. And hopefully we can get through this packet today. So Bohr diagrams is a method for expressing electron location in an atom or an ion. So when we draw these, we can kind of see where the electrons are located. So all electrons must be drawn. And we can kind of say it's Bohr ring. It is kind of boring, but to remember it, the Bohr diagram is a ring. We draw the rings for each level that the electrons are located in. So building on the electron configuration lesson, we look up at the electron configuration of an element at hand on the periodic table. If you're working with an ion, add or subtract the proper amount of electrons from the outer shell of the configuration. So basic example is carbon, which is 2-4, so that's the electron configuration. Then we're going to draw a nucleus with a circle and notate correct amount of protons and neutrons inside. Okay, so we're going to do a little circle for the nucleus, protons and neutrons. So protons, carbon has an atomic number of 6, so it's going to have 6 protons. And then neutrons, remember carbon, mass number for carbon is 12, so number of neutrons, neutron number is equal to mass number minus number of electrons, or protons, I'm sorry, number of protons. So this should be 12 minus 6. That will give us 6 neutrons, positive 6 as the charge on the nucleus. All right, second step, using rings or shells, we're going to call them shells, rings, whatever you want to call them, they're your orbitals. Place the proper amount of electrons in their appropriate orbitals. There should be as many rings or shells as dash number in the electron configuration. So let's look back up. We have 2 numbers separated by a dash. Therefore, there are 2 levels, and then we're going to draw 2 rings on the outside of the nucleus. So we have our nucleus, and then we have ring 1 and the second ring. Sorry for my drawing, guys. All right, so you have 6 protons, 6 neutrons, and then in the first energy level, there are 2 electrons. In the second energy level, there are 4. Okay, and basically they line up with each other on each energy level, and they should be spread out. So the first the first one is lined up with the first electron in the second energy level. Okay, so 1, 2, and then 3, 4, 5, 6. Okay, total of 6 electrons. This is a neutral atom. Remember, protons equal to electrons. Okay, don't forget that. Next, so let's look at carbon again. We just did this, so I'm going to actually use a little box to demonstrate the nucleus. So proton is 6, neutrons are 6, first energy level, second energy level, 2, 3, 4, 1, 2. Okay, so fluorine, and I'm going to give you a few seconds, so I'm going to pause, give you a few seconds to look up the electron configurations for each one of these and try to do the nucleus on your own, and then we'll do the energy levels together. Okay, so now that you've had time to look up the electron configurations for each element, now we're going to do this together. So you have fluorine, all right, and we'll draw the nucleus for each one. It doesn't matter if you do a box or a circle. Okay, so I'm just going to switch it up a little bit. Hopefully I'm giving myself enough room here, but I'm going to be Drawing the nuclei first. All right, so fluorine has a mass number of 19. Beryllium, I looked these up. So beryllium has a mass number of 9. Aluminum has a mass number of 27. Lithium, mass number of 7. Calcium, mass number of 40. I'm going to stick it up there. Sodium should be 23. And sulfur is 32. Okay, and that's how we're going to figure out neutrons. So protons, there are 9 protons in fluorine. Okay, 7, 8, 9. 9 electrons, 9 protons. Neutrons will be 19 minus 9. So we'll have 10 here. 10 neutrons. Okay, protons, neutrons, protons. Right, so this is how we do Bohr diagrams, okay? Make sure that you put protons and neutrons in the nucleus. All right, so beryllium, 4 protons. 9 minus 4 is 5 neutrons, okay? Aluminum has 13 protons, and it will then have 14 neutrons. Lithium has 3 protons, 4 neutrons. Okay, 7 minus 3 is 4. Calcium has 20 protons and 20 neutrons, 40 minus 20. 11 protons here for sodium. Okay, and neutrons will be 23 minus 11 is 12. And the last, we have 16 protons. Subtract 16 from 32, and we get 16 neutrons. All right, now fluorine. Neutral, so we're going to have the same number of electrons as protons, and we have 2 energy levels. So we're going to draw the first 2 energy levels here. First energy level has 2, so we'll use blue for electrons, 2 electrons, and 7 on the outside. 1, 2, 3, 4, 5, 6, 7. Okay, they don't need to be arranged in any way. Just make sure that you can show that there are 7 on the outside. Beryllium. So we'll do purple. Make that a thin line. Okay. So 2 energy levels here. 1, 2. Use red. 2 in the first. And 2 in the second. Okay. Next one, aluminum. So this has 1, 2, 3 energy levels. So we have to draw 3 rings. It's 1, 2, that's kind of close. 3, okay, 3. And we'll use black. So we have 2 electrons in the first, 8 in the second. 1, 2, 3, 4, 5, 6, 7, 8, and then 3 on the outer shell. 1, 2, I'm going to put it down here, 3. Okay. Next one, I'm going to change up the colors a little to make it a little more interesting, I guess. All right, so next, 2 energy levels for lithium. We have 1, 2, and let's take a guess. We're going to say, well, it's not even a guess, but 2 electrons in the first energy level and only 1 in the outer level. Now this is where it gets a little tricky. Okay, we have to keep in mind this has a charge. So the ions, we just subtract the number of electrons or add the number of electrons based on the charge. So it's a +2. So this is a loss of 2 electrons. Therefore, this will no longer be part of the electron configuration. And we're going to draw only 3 energy levels now. Okay. 2 electrons in the first, 8, 1, 2, 3, 4, 5, 6, 7, I'm going to put another one over here, 8, and then 8 on the outer, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Lost 2 electrons, therefore that last energy level disappears. Okay, well, it doesn't really disappear, but it doesn't have any electrons, so therefore it's empty. So we don't really have to draw it. You can draw it to show that it lost the 2 electrons. So for sodium, +1, so this means this is a loss of 1 electron. Okay, so this means that this one is gone. It's always the outer one, and then we're left with 2 energy levels. Okay, and I'm going to do this really quick. 1, 2, and then 1, 2, 6, 7, 8. Okay, and then finally, the last example here, we have we have sulfur with a -2, so this gains 2 electrons. So therefore we're going to add 2 here, and we're still going to have 3 energy levels, okay, because the third energy level can hold up to 32. So we know that we can fit 2 more in there. So we're going to have 3 energy levels, and now this energy level is going to have 8. All right, so let's do this. 1, 2, then 1, 2, 3, 4, 5, 6, 7, 8, and then on the outside, and we can line them up to make it look nice. 1, 2, 3, 4, 6, 7, 8. Okay? Next, another diagram. So the Bohr diagrams, again, really simple, but just don't forget boring. Okay, so you're putting the rings in there for each energy level. Make sure that you are keeping in mind whether or not it's an atom or an ion. All right. Another way to show electrons are through Lewis dot diagrams, and these are really easy. Okay, so it's a shorter way of expressing electron location. Okay, so this part's not in your notes. All right, so we're going to leave that alone. So it only illustrates the valence electron configuration. So recall that the valence electrons are the outer electrons. So whatever the last number is in the configuration, that is the number, or the number of dots that we're going to draw. So first you have to write the element's symbol. Then you're going to retrieve the electron configuration from the periodic table. The last number in the configuration is the number of valence electrons. Then we're going to arrange the valence electrons using dots around the symbol using the following rules. Only 2 electrons maximum per side of the symbol. Therefore, no more than a total of 8 surrounding the symbol. 8 is great. This means that it has a stable octet, and it's happy. Okay, it doesn't want to bond with anything, and that's just the way it is. It's just going to be happy. Happy, happy, happy. Okay, always pair the first 2, and then if you have more than 2 valence electrons, deal with them one at a time to the other 3 sides until you run out. So let's look. You have 1, 2, and then you're going to go 3 here, 4, okay, 5, 6, 7, and 8. So that's the order of the dots. The first 2 are paired. Then you go at the top for each side, all right? So top dot, 3, 4, 5, and then 6, 7, 8, and back and around. So it's like a rotation. So if you're working with an ion, you must adjust the valence electrons. Again, add or subtract electrons in the configuration before constructing your dot diagram. And be sure to draw your final diagram with the initial charge on the ion. We generally use brackets for ions. And I will show you what I mean in a minute. Okay, so I will give you a second to look up electron configurations for each one of these elements, and you don't need to know number of neutrons, so don't worry about getting the mass number. Remember, this is just valence electrons. So these are really easy compared to the other ones. Bohr diagrams, remember, you need neutrons, protons, and electrons, and the electron configuration. Here you only need to see the electron configuration first. Look at the last number. That's how many dots you're going to draw. Okay, and let's just keep in mind this is how we're going to do our numbering. 1, 2, the first two are paired. 3, 4, 5, 6, 7, 8. If we have 8 dots. So that's how we draw out the dots. 1, 2, the third one, the fourth one, 5th, 6th, 7th, and 8th, so on. All right, so take a second, look up the electron configurations, try to draw the dot diagrams. I have 2 examples of ions for you, and we will do those together because you won't know how to do the brackets yet. All right, so we have argon 288 is the electron configuration. 8 will tell us the number of valence electrons. That's how many dots we're going to draw. So you have to draw the symbol first, argon. Okay, the first 2 electrons are paired. 3rd, 4th, 5th, 6th, 7th, and 8th. Okay, so this one is stable. It's in a stable octet. This is actually part of the noble gases in group 18, and because of these 8 electrons, it does not pair with anything. It will not bond. It's non-reactive. Okay, phosphorus, the next one, we have 5 valence electrons, so draw the symbol. And we could do that for all of them. Carbon, beryllium, oxygen, oxygen again, sodium, bromine, sodium again, and aluminum. So phosphorus has 5. So we start with the first 2 paired up at the top. 1, 2, 3, 4, and 5. Okay, carbon, we have the first 2 are paired, and then 3 and 4. Okay, comes from that number. 2 valence electrons, so we just have 1, 2. 6 valence electrons, 1, 2, 3, 4, 5, and 6. Okay, next, aluminum, 3 valence electrons, 1, 2, 3. Okay, so you're going to have to memorize the way that we put them in order. All right, sodium only has 1, so we're going to put that up there by itself. Bromine has 5. 1, 2, 3, 4, 5. And then I'm going to switch the color of ink because we have an ion here. So we're going to look at this. And we say sodium. All right, so it has 1 valence electron, but it loses its valence electron. Okay, so now it has 8. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8. I didn't do that in order because there's 8, so I'm just going to surround it. So because it has 8, we're going to put brackets around it, okay? And we're going to put a +1 charge. For oxygen, on the other hand, okay, now we have 6 and it gains 2. So now, same thing. 1, 2, 3, 4, 5, 6, 7, 8. It's full, okay? And that's because it gained 2 electrons, so it has a -2 charge. All right, so this will tell us that that last one was lost. Sorry, guys. Let's erase these dots here. Okay, guys, that's the end of lesson 5.